All right, we are looking at word problems. We are just going to do the first three. We're not going to do number 4. Number 1, a fireworks rocket is launched from a hill above a lake. The rocket will fall into a lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by that equation. What is the maximum height of the rocket? Okay, so let's think about this. What path do you think the rocket will take? Do it with your hand. It's going to start here. Everybody go right here. Now, how is it going to go? Up. Right? And then it's going to explode. Then it's going to come back down. Right? So where are we going to find the maximum height? Here or here? Here, right? So we've got to find out what this looks like. So real quick, let's make a little graph. And we're going to put it on that graph. The x-axis is going to represent time in seconds. Leave a little bit of room so we can put some numbers there. And then the y is going to be our height in feet. So we're going to figure out some key features of this equation by putting it in Desmos on a graph. So let's go to Desmos. Let's put that equation in. You can put g of x equals, or you can just put y equals. Wonder if this will work. I'm just going to try it. No, it won't. Y equals negative 16 x squared plus 64x plus 80. Okay, so now I'm going to make this one full screen so we can kind of see an idea of what it looks like. Okay, it's hard to tell anything here. So we would zoom out. Well, let's just see what the x-axis is going to go from. If we're talking about time in seconds, where would we start on our x-axis? Where do you think would be a good starting point if we're talking about time, that the rocket is up in the air? 0. And then how long is it going to be in the air? Click at the x-intercept. It's going to be at 5 seconds. Okay, let's figure out how high it's going to go. So let's zoom. Click on the highest point. What's the highest that this rocket's going to go? 144. So we're going to use that to help us. So I want y'all to write something down, though. Okay, so I know that I want this graph to go to 5 seconds. So I'm going to do 1, 2, 3, 4, 5. So we're kind of setting up what our graph should look like. And then what was the y-axis? What was the highest that it went? 144. So we need to go to, I guess 144. But what if we go by tens? We'll actually make it to 150. So let's do that. 10, 20, 30, 40, 50, 60. Oh, this is going to take a lot. There's not enough room. What should I go by instead? Let's do that. Sorry, guys. Sometimes, yeah. Let's go 20, 40, 60, 80, 100, 120, 140, and 160. All right, that's better. Okay, so for our window, we are going to use this information to set up our window on Desmos. So I want y'all to put window here. The x values are going to go from 0 to 5. So see how my x-axis is basically 0 to 5. So let's go 0 to 5. 0 less than or equal to x less than or equal to 5. It's our domain. Remember doing that? We're just setting up what values are important to this situation. And then our y values. What's our lowest y value that we'd want? We'd want the bottom, but we don't really want any negatives because we're talking about height, right? So we're going to go 0 to what? What do you think would be a good number? It goes up to 144, right? So let's do 150. So let me show you how we're going to input this on Desmos. You see the wrench up at the top on Desmos? That allows us to adjust the window without just zooming in and out. So I'm going to put this into Desmos. So if you just click it, it'll highlight the whole thing and just put a 0 over the top. Then just click the other number. Oh. And we're going to put 5 there. Then y, we're going to do the same thing. 0, but the y goes to 150. Okay, look at it now. Is that a lot easier to imagine what it looks like? All right, we're going to just zoom it a little bit just so we can see the x-axis and the y-axis. Now we're going to copy this down on our graph that we drew, our little graph. So we know it ends at 5. It's going to start at 0, but how high up is this rocket launched from? Click it. How high up is that? 80. So that's how we're going to start our drawing. So go back over here. We need to start it at 80. So put a dot there. I'm going to do it with a different color. 80. And we know it ends at 5. So I have 2 dots. I need a third. So where would I get that third one? I'll put those numbers here. What is the vertex? That's that highest point, the maximum point. 144. So let's make sure to graph that. 244. So it looks like it's probably like that. Okay, so now draw your parabola. So we know it's going to go like that. Something like that. Alex, can sit right here. Hopefully your parabola looks better than mine. Okay, so then we have to answer the question. What is the maximum height of the rocket? Where do we find that maximum height? Isn't this the max right here? What did we say that was? Yep, so 144 feet. Okay? Make sure you're following along and putting it into Desmos because this is what your project's going to be. Tomorrow after your CBA, you start your project.
So just for you just put the highest
Yep. Your highest and lowest numbers for X's and Y's for your graph. be Thursday. All right, let's look at example 2. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground, x seconds after it's thrown, is given by that function. How long after the rock is thrown does it hit the ground? All right, so let's draw a picture of this. What's it going to look like? Huh? A rock is thrown from the tall building. So where is it going to start? Is it going to start here on the ground?
It's going to start from a tall building.
It's going to start up here, and what's going to happen to it?
It's going to fall down.
So it's going to go down like this, like a parabola. So let's draw the x and y axis. Draw x and y. What did it say x was? Distance in feet, x seconds. So this one is that same thing, time, seconds. I'm going to abbreviate seconds. And then y is going to be height in feet. And it tells us that in the paragraph. We don't know numbers yet because we don't know what this looks like. So type it into Desmos. What is our equation? Y equals what? Negative 16x squared minus 4x plus 382. Okay. So the window that we had made earlier that we adjusted doesn't work for this one. But we can kind of look at it like that, right? We can zoom out a little bit. So let's come up with the important details. How high up does it go up to? 382. So that's our max. So we need to go up to 382. What should we go by on our y-axis? What do y'all think? 100? So 100, 200, 300, 400. So it's going to start at that 382 mark. And then how long does it take it to drop to a height of 0? What was the x-axis at? Yeah, like 5. Almost 5. So we should go by ones. 1, 2, 3, 4, 5. Let's figure out our window. So you'll always want to start it at 0. So 0 is less than or equal to x. And then how far do we need to go? We can round. We don't have to put 4 point whatever. So we'll round that to 5. And then what about our window for our y? How high up did I do on my graph that I sketched? 400. So now that we have the window set, we've got to decide where does it start and where does it end, and then graph it according to that. So look back at Desmos. And my window got messed up. Oh, or we haven't put the window in, have we? I just thought about that. Okay, so go to the wrench. And we are going to set up the window like this one. Let me see if I can get it to... There we go. That looks better. All right, go to the wrench. Everybody needs to practice this, okay? 0 on the X to 5. And then the Y is 0 to 400. So I need to see that everybody has that in their Desmos.
Miss, I just look. I'm trying to figure that out.
On Desmos? Let's see. Full screen. So it should look like that. And so what I changed was the X was 0 to 5, the Y was 0 to 400.
Where's it?
It's the wrench, a little tool.
You changed the what again?
Do what?
The wrench?
The wrench.
What did you change?
You change the X, 0 to 5. X, 0 to 5. And then the Y is 0 to 400.
You know the wire?
Yeah, it's not shaky.
What about the wire? You don't do the wire? You don't do the wire? No, you don't do the wire. So, 0.
And then try again. Just click over here.
Can I
Okay, once you get that in, you can still adjust it a little bit, but it does make it easier to see the whole picture. So let's figure out what the top point is. Where was it thrown from? It was a rock, right? Thrown from 382. So I'm going to go here. And 382 is about, so let's say, 382 would be like right here. So go ahead and write 382 there. And then it hits the ground after 4.76 seconds. So it goes like this. Something like that. So 4.7, 4.8, 4.76. Okay, so these are all the things you should have written down. And then you'll answer the question. The question says, how long after the rock is thrown does it hit the ground? So we would look at the picture. It would be this location right here. That's where it hits the ground. So 4.76 seconds.